In this video, we will be building a 4-to-1 multiplexer. In this situation, we have two switches to represent the possible inputs A, B, C, and D. We'll wire a 74150 multiplexer integrated circuit and use an Arduino to test to make sure it's working. Our next circuit will be controlled by two switches. It is grounded, once again, at the bottom left, powered from the top right. This is a 74150 multiplexer. It takes in two inputs, which go in on the side next to the power. It can take a total of 4 inputs, but in this case, we're just going to use the second and the third from the bottom. So here's our first input. And then the second input is just above it. We'll add in an additional connection to ground at the bottom right to represent a third potential input, and another that is right next to ground on this side. We need an additional connection to ground on this side to represent strobe that goes in the fourth from the bottom. And then the one that we skipped over is actually our output. The trouble is that our output is actually inverted, so we need our 7404 chip again to be able to output what we want. So this one also needs a connection to ground on the bottom and connection to power on the top. And then we're going to run a wire that goes from that third pin from the bottom on the left to one of our NOT gates on this inverter chip. And then it will have a connection that runs back from the output of that gate to our LED. Now you would think that we were done at this point. There's plenty of complicated wires on this board, but the next part is actually putting in inputs. See what a multiplexer does is actually decide which input ends up being output. So for right now, we're going to go ahead and mimic having additional switches by plugging wires directly into power. Our input wires are going to go on the side directly next to our 4 at the bottom. So here I've got a yellow wire, an orange wire, a green wire, and a purple wire. So we're going to start with the purple wire connected to power. And purple wire is our input 3. So if we name these, yellow is 0, orange is 1, green is 2, purple is 3. So we plugged our purple wire into power. We plugged in orange, yellow, and green into ground. So what we should see is that if these switches are in positions 0, 1, or 2, so if either one of them is on or both of them are off, but not the case where both of them are on. We should see nothing light up, but if we turn both of these on, we see it light up. Now, if we change out our green wire, which was number 3, now we turn on just wire B, then it'll light up. And if we change out where that wire is connected to, it ends up showing that that is controlling the output here. If we change to our second input, which is the orange wire, it should be off right now. If we unplug it from ground, plug it into power, it turns on. When we turn both of these off, we should still see that the yellow wire, which is our number 1, the yellow wire is currently in control of the output because the switches are both turned off. So the yellow wire is number 0 and is currently in control. If we go ahead and put number 2 back in ground and number 3 back in ground, we should see that when we turn the switches, the 0th input, when both of them are off, will be connected to power and therefore on. If we're connected to 1 or 2, so either one of these switches are on, then the output should be off. And then when we connect both of them to being connected to power, so then if both of them are connected to power, we should see the LED turn on as well. So here we are with neither of them turned on. We turn just one of them on. We are not connected, but if we turn both of them on, now we have a connection to power. So the beautiful thing about it is that these 4 wires do not have to be connected directly to ground or power. We can connect them to other things, and that means that we can dynamically switch between inputs. In order to show dynamically changing between inputs, we're going to go ahead and connect to an Arduino. So we are putting in input 0 will go in 10, input 1 will go in 11, input 12 will go into 2, input 2 will go into 12, and then we'll remove the tiny wire that we used for input 3 and use a longer wire that connects to input 13. Now we also need a connection that goes from ground into the ground of our breadboard so that we have a full and complete circuit when we attribute power. Next, we're going to connect the Arduino to the computer. So here we have the Arduino set up with its 4 inputs. We actually need the A and B inputs, instead of coming from the breadboard, to be coming from the Arduino as well. So in addition to the 4 inputs that are going to the Arduino, we also need these 2 select bits or switches to be coming from the Arduino as well. So we're going to connect A and B to pins 9 and 8. So for the Arduino, we have a setup with 4 connectors to inputs 0 through 3. We have an output that's going straight into pin 7. And then we have our selector pins going from A and B to 8 and 9. So now we have the Arduino plugged in. We're going to go ahead and record the code to make these inputs get tested.